Okay, in this video lesson, we'll be using trigonometry to determine a missing part of a right triangle. The primary focus here is to help you develop a strategy for actually creating the equations that you'll eventually solve. So, let's look at it. There's a general format that every single equation will follow. The format is, it'll start with a trigonometric function, followed by an acute angle, followed by an equal sign because we are creating equations, followed by a ratio of two sides. Specifically, when we speak about trigonometric function, our options will always be sine, cosine, tangent. The primary trigonometric functions listed on our calculator. Theoretically, you could choose the cosecant, secant, or cotangent, but we will focus in on those primary sine, cosine, tan, primarily because we will be using the calculator to assist us with solving. With respect to the acute angle, you'll either use the theta symbol to represent either an actual quantity, or if the angle is the unknown amount, we'll use some symbol to denote that the acute angle is what's missing. Followed by the equal sign, again, because it's an equation, and the ratio of sides will always be using the three words opposite, adjacent, and hypotenuse. Here's a couple examples. Cosine 15 degrees equals a over 23. Cosine represents the trigonometric function. 15 degrees is the acute angle, the equal sign, and our ratio of two sides, a over 23. In this particular example, the a represents the adjacent side and the 23 represents the hypotenuse. I know that because we're using the trigonometric function cosine, which is the ratio of adjacent over hypotenuse. Another example, tangent theta equals 3 over 4. Tangent is the trigonometric function. Theta is what we're using to represent our acute angle. In this case, the acute angle is the unknown quantity. So we're using theta kind of like we use variables in algebra. When we don't know a particular angle, we'll use the symbol theta. There's our equal sign followed by the ratio of our two sides. In this case, 3 is the opposite, 4 is the adjacent, because the trig function is tangent, which is the ratio of opposite to adjacent. One more example. Sine of 38 degrees equals 15 over c. Sine is a trigonometric function. 38 is the acute angle. There's our equal sign and our two sides, 15 over c. In this case, 15 represents the opposite side and c is the hypotenuse because sine is the ratio of opposite to hypotenuse. So we'll look at some steps to actually create these equations. So steps for setting up a problem involving trigonometric functions. So step 1 says identify the acute angle that's referenced in the problem. Once we do that, now that we have the acute angle, we can then begin to name the sides referenced by the acute angle. The possible sides will obviously be either be opposite, adjacent, or the hypotenuse. Next thing, now that we have two sides, we can then start to narrow down the possible trigonometric function. The trigonometric function we use will be associated with the two sides that came from step 2. Step 4 will now begin to substitute everything we found in the previous steps into the general format, which is the trigonometric function followed by acute angle, equal sign, and the ratio of two sides. Last step is to actually solve for the unknown. So let's try a few examples. Determine the length of BC, round to the nearest tenth. Well, step 1 says identify the acute angle referenced in the problem. Well, we're working with angle B. I know that because it's the only acute angle that actually has a value in it. Step 2 says, now name the sides associated with that angle. Well, here we're working with the A and the 29 inches. A happens to be adjacent to the acute angle, while 29 inches represents the hypotenuse. So the next step says go ahead and create your two ratios. Well, we either can put adjacent over hypotenuse, which represents cosine, or we could have actually done hypotenuse to adjacent, which is secant. As recommended, we'll choose something that's a little bit more user-friendly, something that's on the calculator, cosine. Step 4 says, go ahead and substitute everything into the general format. Well, the general format says trigonometric function, which we would determine from step 3, acute angle, which came from step 4, the equal sign, and the ratio of the two sides. What we saw in step 3, cosine was adjacent over hypotenuse. Step 2 told us the adjacent was A, and the hypotenuse was 29. So step 4 says, go ahead and solve. Well, algebra says A was being divided by 29, so let's multiply 29 on both sides. 29's cancel, leaving me with 29 cosine 13 is A. We type that directly into the calculator, 29 cosine 13. Calculator says 28.3 inches, and it's 0.3 because it was told to round to the nearest tenth. Let's try a couple more examples. All right, it says determine the measure of angle E, round to the nearest degree. Step 1, identify the acute angle referenced in the problem. Here, the angle reference is E. How do I know that? Because in the original question, it says determine the measure of angle E. That's the angle we're working with, or more specifically, the acute angle we're working with. Step 2, let's name the sides that's referenced to angle E. Well, it looks like we're working with 31 feet and 23 feet. 23 feet happens to be the side adjacent, while the 31 feet happens to be the side opposite. Step 3, let's create the two ratios. Well, we're either going to have adjacent to opposite, cotangent, or opposite to adjacent, tangent. Here again, the recommendation says go ahead and choose what's on the calculator. Again, this is not to say you can't choose the other ratio, but the tangent is probably the more straightforward one because, again, we will be using the calculator. Step 4 says let's substitute everything in. The trigonometric function, we said from step 3 was going to be tangent. Step 1 told us the acute angle, angle E, the equal sign, and the ratio chosen from between steps 2 and 3. Step 3 says opposite to adjacent. Step 2 told us the opposite was 31 feet, the adjacent 23 feet. Let's solve. That's step 5. Here, the unknown is being, if you will, tangented. So I'm creating a verb, an action, an operation. And the inverse of tangent is inverse tangent. So we'll inverse tan on both sides. The tangents cancel, leaving me with angle E, the measure of angle E. So into our calculator, inverse tan 31 over 23. Calculator gives us an angle amount. Notice it says round to the nearest degree. That's why I'm rounding to 53 degrees. Couple more examples. All right, determine the length of PR. Round to the nearest hundredth. Well, step 1, let's name the acute angle reference. The acute angle is our 74 degrees. Step 2 says let's name the sides referenced by the acute angle. Here we're working with the 57 degrees and the cube. The 57 centimeters and the cube. The 57 centimeters is the opposite side, while the cube is the hypotenuse. So step 3, let's create the possible ratios. It's either opposite over hypotenuse or hypotenuse over opposite. So our choice is between sine and cosecant. The recommendation, let's choose sines on the calculator. So step 4 says substitute it into the general format. So the trig function is sine, the acute angle 74 degrees, and our ratio is 57 over q. So step 5 says let's go ahead and solve this. Here we have a unique scenario where our unknown is in the denominator. So technically nothing is being done to the unknown. 57 is being divided by q. Q is not being divided by 57. So we have a predicament here. So here's the suggestion on solving this. One suggestion is simply to create a proportion. Now I'm going to go through all the steps, but after we complete the steps, we'll see a pattern so we can avoid all the work. Because I've created proportion, since middle grades, we solve proportions by cross multiplying. So the sine 74 degrees times q gives us q sine 74, and the 1 times 57 is our 57. The benefit now is q is being multiplied by sine 74, so we'll simply divide sine 74 on both sides. The sine 74 is canceled. Now I have something to type into the calculator. 57 over sine 74 gives me an answer of 59.30, rounded to the nearest hundredth. We have our answer. But let's look back at how to be able to avoid all the work we did in creating the proportion. The original equation was sine 74 equals 57 over q. The predicament was we had the q in the denominator. But when we compare it to what we ended with after doing all the work, looks like just the q and the 74 simply switched places. We're able to simply switch these places because when it was a proportion, all we did was multiply these two values. Well, the commutative property tells us we can switch the order and still get the same answer. Let's see if we're going to apply that understanding in this problem here. So, step 1, identify the acute angle. There's our 12 degrees. Step 2, the two sides, 4 meters, and S. S happens to be adjacent, 4 meters happens to be opposite. Our two ratios, adjacent to opposite and opposite to adjacent. So with the choices between cotangent and tangent, we're going to choose tangent. It's on the calculator. So we create our equation using the general format. Trig function, acute angle, side to side. When we begin to solve our equation, we're left with the similar predicament we had before. The variable is in the denominator. So now we will apply our understanding of what we did last time. We simply switch the order because we're applying the commutative property of multiplication. So we simply type 4 divided by tan 12 into the calculator. Calculator says 18.82 meters. Again, it said round to the nearest hundredth. So the examples that I illustrated are the only possible examples or situations you would ever have to encounter. So hopefully this video lesson will give you the strategies in order to set up the equations and solve any possible scenario.